All right, let's solve one last example from chapter 10. It is question 233. So let's read the question first. Question 233. The generator coil shown in the accompanying figure is rotated in the magnetic field. The 200-turn circular coil has a 5 centimeter radius and is in the uniform 1.2 Tesla magnetic field. The peak voltage is 200 volt. Find the velocity, the angular velocity or angular frequency, depending on which term you prefer, in RPM. So we got a couple of pieces of information. We got the number of turn, 200 turn. We got the radius. We are also told that it's a circular coil, which means we can find the area from the radius. It is equal to pi r squared. In this case, it is equal to 7.854 multiplied by 10 power minus 3. The magnetic field is 1.2 Tesla. The maximum voltage, the peak voltage, is 200 volt. Now this is the formula for the EMF. The peak voltage happens when this term, sine, is equal to 1. Sine cannot get bigger than 1 or lower than minus 1. So if we want to find the peak voltage, we have to set this to 1. Now, once we have this turned to 1, we got all the data except for the angular frequency. So the EMF becomes 200, number of turns is 200, magnetic field is 1.2, area is 7.854 multiplied by 10 power minus 3, and we got the angular frequency over here. We isolate the angular frequency and we get 106.1 radian per second. Now we want to convert the radian per second to the RPM. So the angular frequency in radian per second is equal to 16.89 revolution per second. Okay, so you could, if you wanted, go from the radian per second to the value in RPM. But generally, I like to break it down into two steps. I take radian per second and I divide by 2 pi. This will give me the number of revolution every second. Now remember, there are 2 pi radian in each complete revolution around a circle. So this value is the number of revolution every second. Well, in 1 minute, we have 60 seconds. So if we want to get from this value, we can get the value in RPM by simply multiplying by 60. So the angular frequency is equal to 1013 RPM. All right? So that's it with chapter 10. We are going to be switching to chapter 12 now, which is the last chapter of this semester. So see you in the next chapter.